Alrighty, tidy, folks. Welcome to sort of an early morning. Yeah, 0900. Started about an hour earlier today than I have been. Don't know yet whether I like it or not. Uh-oh. Okay, we're gonna move this guy kind of like that. So I got a couple of things I want to try to get done today. Pacific ECU mods, wildly successful. Huzzah. I got a little screen grab of the data out of the finished product, and I think it's pretty good. I didn't design. I did the math and determined that 70 hertz was what I had parts on hand for and would be acceptable / sufficient / sort of ideal for the EGR lift input, i.e. the wideband sensor, the lambda sensor input, and it does. So the ECU, I'm not quite certain how often the MCU pulls the OEM narrowband air fuel sensor. The sensor data itself that Neptune views is live, and I haven't really calculated its update rate. Sneasels, excuse me. Haven't really calculated its update rate quite yet. I'm also going to turn you guys just a little bit more. I can see myself in the lens. As I was saying, I haven't calculated the update rate of the O2 sensor yet, the response time of the O2 sensor. I'm sure if I spent 5 or 6 hours looking around on websites, I could find it. The part that's in there now is a Denso part, which is the OEM part that Honda installed when the part that they designed the control system around was that particular Denso part. We got the OEM one in there, and it's cool. Remind me sometime, and I'll show you kind of a funny. I can tell you the funny, but remind me sometime, and I can show it to you. So at one point, I don't think I've released the video yet. So I got to finish cutting together the video where I replaced the reverse connector on the Civic because the harness side, the wire broke out of it. It's a standard thing that happens to older cars, especially older cars with connectors and larger wire harnesses, right? Fuel injected cars. So right at the connector, the wires, there's a lot of stress on the wires, and the insulator gets brittle, and you get a little tiny bit of corrosion in the copper, and then it just breaks. Not unusual, not unheard of. The connectors are easy enough to find. You cut it back to the good wire, solder it so you have a good connection, heat shrink it so you get corrosion resistance. Add a section of good wire back into it. New connector, new crimps, everything's golden easy peasy. I've got my bucket of wire harness. I got like 10 different wire harness segments in there from Civics, so they're all the correct wire colors and lengths and what have you. And I've just been, over the years, as wires break, I'll rob wires out of it, because in the middle of the harness, the wires are perfectly fine. Especially any of the harness segments that have been inside the cabin. All those are fine, because they're not out in the heat in the engine bay getting heat cycled and just heat cycled and oil and coolant and whatever else on them that tends to degrade the, I believe it's PVC jackets on these guys, because they're kind of stiffer wires. Of course, they are larger conductor strands inside the wires also than I am accustomed to. But I imagine that's because most of the stuff I'm accustomed to is electronics, specific audio equipment, visual equipment, all that stuff. And with AV equipment, with headphones, with speakers, you would prefer smaller strand with a higher strand count in the same conductor cross-sectional area, then you would prefer a lower strand count with larger conductors. The automotive world is a little bit different, higher vibrations. You don't want wires breaking. The smaller strands will break due to vibration faster and more often, so it makes sense. It's not a complaint. It's just an observation. But grabbed to take a drink and then I just set it back down. But I've got to cut that video together and show you guys. Just talked to a guy that wants me to take a look at his van, see if we can't figure out how to add some lights that were not the factory option. So we're going to give that a go whenever he comes on by and brings that. I've got a couple of things that I kind of want to do and or look at today. If I had a helper, I'm not going to touch the Accord. Oh, I said I wasn't going to touch it. Oh. I'm not going to do the Accord until I get the cable for the Logitech and the microphone, and I can get it all set up and working. I just ordered those Sunday, I think, Sunday afternoon, Sunday night. So the orders will be going through this morning, and they will be shipping out. I can actually, real quick, let's go take a look. See if, I doubt either one of them is shipped. One is active USB 3 cable, 15 meters, 16 meters. Can't remember. The other one is 2, because I couldn't find a single long cable. 2 TRRS 10-meter cables? 25-foot cables. So, what would that be? 8.7, 8.8, maybe 9.1 meters? I don't know. But I ordered, I don't know if you can see that. Yeah. Whichever. But I ordered those. They should be here. One says track package, which I assume means the label was printed. Actually, 23. It says Sunday, yesterday. Wow, package arrived at carrier facility at 21:13. And then carrier picked up the package at night noon this morning. Cool. The other one, the one that's infinitely more important, because the whole purpose of this channel is to show you guys what these things look like and what to look for when you're looking at some of this stuff, and to give you the tools to arm yourself to be able to do this stuff yourself. Because honestly, at the end of the day, you'll probably hear me say it all the time, I'm kind of brilliant, right? I'm a very not dumb person. And while being measurably above average has helped, has done a lot for me, at the end of the day, my skill is simply reliant on my ability and my willingness to give it a go. give it the old college try. Even though I'm not a dummy. Actually, tell you what I'm gonna do. I'm gonna big face you guys. We're gonna go big cannon. Bam. We'll do that. How's that? Oh, we got the Asus up there too. Hi. I didn't remember that being on there. Whatever. We don't actually need the Logitech either. There we go. Okay, so like I said, while being kind of brilliant does help, it can only take you so far, right? At the end of the day, you can be a genius. You can have an IQ of 250, but if you don't get up and do it, if you let your anxiety or you let your what's that other thing? I got a hair. There's a funny hair tickling my ear. If you let your anxiety keep you from getting up and just doing, that I want to say is probably the biggest detractor for people who are like, I'd love to be able to save some money and do it myself. I don't know how to do it. Like, sorry. It's less about knowing how to do it and more about knowing where to start, I guess. Knowing what you need to look for or where you need to go. And that right there, like literally that is one of the key reasons I have started this channel. And I haven't been releasing videos as much the past couple of weeks because most of the stuff I've been recording is multi-parters, it's waiting on parts, it's I don't have a cable to go and show you guys what I want to show you guys. It's whatever. I've got a dozen reasons for me being lazy and not posting videos. At the end of the day, I'm just lazy and haven't been doing it correctly. The stream has helped. It's helped me structure. It's helped me organize my doing. Because before I started streaming every day, I would just kind of languish and wallow in my own self-pity, really, until there was a job that I had all the parts to do, and then I'd do the job, right? Because at the end of the day, I will tell you, I'm lazy, I'm a procrastinator, but I'll get the job done. The job will get done. It's funny, because I call myself a procrastinator, but the facts belie my face. Because I'll do the job before I'm lazy. That's generally my format. This thing. It's the same thing every day for the last like month and a half or so. I don't know what it is. Something in the air. Maybe that just means I need to I need to move. Maybe that's what that's telling me. Maybe it's just telling me I need to move. But I've got some things I've got to do. I've got these TPMS sensors for Schrader. Bam. TPMS sensors for the Pilot that, according to my roommate, are the correct part. Guess we'll find out, won't we? They're sitting there. The Pilot is at work. It's not here. I did check the VDub again this morning just to gather more data. More data is always good. And I am now 100%. Yesterday, I was 98% certain it was a transmission computer. Today, right now, I am 100% certain. And I totally didn't text my friends my stream. So let's do that real quick, folks. Wait. Just keep a YouTube tab open, right? So bam. Jeez. Stand by. like to avoid doing that in your guys' ear. Ears? Ears. Ears. Are you wearing one headphone, or you only have one ear, or you're wearing both headphones, and you have 3 ears? I don't know. Whichever. Yeah, pretty sure that's today's. It says one watching now. Hey, Multiplayer Monday. Scrapman, Khan, Moonbow, and now featuring Cosmonaut. I like Cosmo. He seems like... Cosmo strikes me as the kind of guy that I'd probably be friends with in real life. And instead of starting a channel and doing some stuff, he's been doing automation and BMG stuff, and I'm kind of tempted to see if I can't, like, get in game with him sometime and just, you know, do some car stuff with him, because, I mean, you know, car stuff. I remember the, what would you call that, trailer or demo for automation quite clearly. And it was a kind of a smaller demo. It wasn't huge and expansive. And I remember thinking, wow, when that comes out, I am gonna get it. And then I completely forgot about it, because I don't do like wish list stuff generally. I just recently added things to my Steam wish list, because I'm like, I'm gonna forget the name of these games. I am. So I forgot about it, and then Cosmo started making videos about it. And I gotta figure out how to export the stuff from like automation to BeamNG, which I don't think is too hard. But what I'd like to do, honestly, what I think would be fun, is record some sound bites, record some data, get in Anje's engine simulator, recreate the Civic, and drive it around in BeamNG. How awesome would that be? Drive your real car in BeamNG. That would be cool. That's what we should do. Because Cosmo has a loud car. He's got it like cat delete or something. And his car is kind of loud, apparently. Just things we talk about, like in the comments on his videos or whatever. I'll say something, you know, oh yeah, my car's like that too. You know, that kind of thing. Not that I talk to the guy on the regular. Not that we're friends in real life or anything. But yeah, like I said, he strikes me as the guy that we'd probably be friends in real life. If we ever actually meet for real and sit down and talk and what have you. Bam, 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 ba, ba, ba. That's a different URL than the last one. I need to vary the stream names, I think. I haven't been doing that. That might have been the one. So, some of the things I want to do today, I started this thing, was it yesterday? Or was it Saturday? Got this little bucket thing here. And I dumped one of my rear seat belt from the Civic. Rear seat belt clip, receiver, whatever you would call this thing. And what I'm thinking is I want to attach this to the seat as opposed to the hard-mounted guy. So yeah, so what I've got is this guy, right? Man, that lens is, it's always so much wider than I think it is. You see just a tiny bit of, what do you call that, vignetting on the side there from all of the freaking add-on lenses that I put on here. And I've got a hole in my elbow, and it's really annoying to set my arm down on things. But, yeah, we've got this guy that he's not quite clean yet, but You know, he's getting there. I could scrub him up a little bit, couldn't I? That water is quite not warm. Alright, so... Man, I was talking about the V-dub before I started going off on a tangent, wasn't I? Yeah, so I am 100% certain the transmission computer is at fault. The issue appears to be internal to the transmission computer, and perhaps one of these days we'll get on stream there. I'm motioning at the Logitech, which I have turned off, so that does you no good. Ah, the cannon's slow. You're slow. I do need a new, longer, active USB micro cable. Actually, it's not micro, it's mini. It's USB mini. I lie. I'm hoping the issue is the cable, because with USB mini, more often than not, connection, positive connection, tactile response, haptic response on USB mini cables is largely down to the cable. I did see something that was like USB mini reversible, and I was like, not a reversible format. How are you? What? Like they tried to USB-C a USB mini? I don't think that's a thing. But what do I know? Okay. So, yeah, I don't want to touch the Accord until I get at least the video cable that I can hook up the Logitech and drag it underneath the car with me and show you guys exactly what's going on. I gotta get my roommate out here. It's quite funny. Sad, annoying, slightly irritating, going to be sort of expensive to repair, but kind of funny. I don't want to spoil it. I don't want to spoil it. I want to show you guys. Jeez. I mean, the Accord, it's a great car. Most of it's a great car. The cluster and the electrical system that was apparently designed by Americans, because it's not all that good, they're not all that great. Cluster was subject to the standard American manufacturing defects, cold solder joints, because Americans apparently don't know how to solder correctly, I guess. I don't know. Hugely common problem in these cars. Multiplexer fails because cold solder joints on the cluster, the connection does that because they're bulbs, they're averaging, so you don't see the flickering on the dash until the multiplexer driver, the PWM driver, has failed because of excessive transients and voltage spikes due to transients. But funnily enough, one of Honda's most successful and reliable engines, the J series, the J30, 32, 34, I think there's a 36. J series V6, VTEC V6. American designed. Strangely enough. So I give the guys that designed it props. I have a feeling they were probably Honda enthusiasts that had designed it, because the thing's designed correctly. You look at the way it's built. It's built correctly. It's designed correctly. It's put together correctly. It's the way the engine is organized is done correctly. It's not like some ridiculous set of nonsensical things that you have to take apart that have nothing to do with a system that you have to repair just to repair that system. It's not that. You want to do the EGR valve? 4 bolts and a connector. Pull it out, put it in, done. Job's a good one. Actually, I don't even think it's 4 bolts. I think it's 3 bolts. Yeah. It's there's 3 bolts. 3 bolts and a connector. Bam, done. You might, if you're really, really feeling it. What the hell? Oh, that's not good. I got a tube free. That tube's not supposed to be free. It's supposed to be in the hole. Who knows how long I've been driving around like that. Anyway, TPMS sensor. Bam, right there on the side. With Honda's standard, those might be Phillips. Hold on. Stand by. That's weird. Okay. Nope. Those are torque to yield screws. So Honda's standard, we set this TPMS or we set this TPS sensor. Don't touch it. Leave it alone. Leave it alone. You're not us. You can't do it. Which means, funnily enough, I don't know if this era shares the same format, but something Honda did that was dumb in this in the previous era, at least previous 3 eras at least, was because they have torque to yield bolts on the TPS sensor, throttle position sensor. It's not meant to be removed, it's not meant to be replaced. The intention is that you buy a new throttle body. You know how much a throttle body is? I'll tell you this, it ain't cheap. I want to say the last time I looked it up, it was like 500 something bucks. It ain't cheap. Some of the things I want to do today is I want to get this seatbelt thing cleaned up before it starts to corrode on the inside there. Get it cleaned up, get it dried out, spray some lube down in there. Pull the driver's seat back out of the Civic. Attach that, figure out how to attach that guy to it. I might be able just to attach it straight. I might not. I don't know yet. We'll burn that bridge when we get to it, as usual. I would like to sit down with my handy dandy user manual, operator manual here for the Simpson AN PSM 4A. So that's Alpha November / Papa Sierra Mike -4 Alpha. I can show you what that looks like, actually. So that guy there, that's backwards, isn't it? Hey, how do I keep doing that? Like, seriously. And then unlock. Bam. Bam. Hey, now I can read it. Look at that. Alright. I think I keep undoing that because I keep changing the camera and doing other stuff. I don't know. I'm too stupid to figure it out. Anyway, I have this guy. And the cool thing about this guy is this page. Yeah, it's right there. The Schemioetic. There's actually 2 or 3 pages of schematic. Suffice to say, that's the schematic. Also, that section. Parts list. So I need to sit down, go through the schematic and the parts list. The AC function doesn't work correctly. When you put it on AC, it should... Where's that guy at? Oh. I feel like... sometimes I feel like a... electronics-oriented Adam Savage. Just the way I talk, like I never realized that he talked and just the way he was, because all I know Adam Savage from is MythBusters, and A, that was when he was a lot younger than he is today, and B, you're there, you're in character, you're there for the show, and it's a whole different thing than just being at home yourself being you, right? You do things differently for the show, for the character, for the content, for the production value than you do when you're just being you. And now, when he does, the stuff he's doing today, he does it just being him. He's no longer, the showman. He's just Adam Savage because he can be. Because Adam Savage is kind of cool. He's just a cool dude. All right, so we have this guy, right? I'll show him to you a little bit closer. So we have this guy, and it's just your standard, voltometer. It's a big guy so that it's easy to read, and it's got a bunch of functionality in it. So they put a bunch of stuff. There's a stuff packed on the inside of this thing. This one in particular was built sometime in the 50s or 60s. I can't really find a whole lot of information on it, but there's a serial number, and I want to say I looked it up, and it was built sometime, some number of years ago. That just crazy that it still works today, kind of thing. I've got stickers on the back where I took it into my last job because I had a couple of things that required this type of measuring device. And my work, my last job, all they had, okay? So we're talking, this is a facility that builds, that manufactures, tests, and repairs prototype of hardware, electronics hardware, for various customers, military customers, biomed customers, etc., etc. So they do prototyping. It's prototype PCBs and circuitry, and we run the tests that the customer has engineered and provides, or sometimes we come up with the tests. I don't work there anymore. Sometimes they come up with the tests. That is the very rare case. Generally speaking, it was the customers would choose to come up with their own tests because it would just be cheaper for them to do it in-house than to pay somebody else to come up with the testing, the engineering team to come up with tests. So all the tools that we had at our disposal at this place, if you were lucky, you'd get a Fluke digital multimeter. If it was an RF circuit, which most of them were, when I was working there, I would claim that at least 70% of the equipment that we produced and shipped to customer, tested, etc., were RF equipment. Not all of the equipment had RF testing on the benches. But if you were lucky and it was a piece of hardware that its sole primary purpose was as a piece of RF equipment, communications equipment, you would end up getting a spec-an, signal generator, something capable of generating I&Q signals, which was sometimes the signal generator or the spec-an. Some spec-ans can do it. Sometimes, depending on the bench and the age of the hardware, because we had stuff that was designed in the 90s that we were still producing and calling prototypes. Government. You would get hardware attached to that bench, and it was set up for that equipment. So changing it and using it kind of on a debug bench was next to impossible. the company's format was to hire kids with high school diplomas to try and be service cell technicians on prototype PCBs and hardware. And while that might work for the production system, where all the amount of knowledge, prior knowledge you need is, do you know how to make your brain tell your hand to push a button? A little bit more complicated than that. You're running, multi-million-dollar machinery, so it's a little bit more than that. But high school graduates with no technical training whatsoever can run the manufacturing systems. Because most of it's automated and set up by engineers, and then the operators are there just to make sure nothing breaks while it's working, because it's a machine. Half the time it doesn't know how to tell whether it's going to break itself or not. Most of the time it doesn't know if it's going to break itself or not. But they try to do the same thing for Service Cell, which Service Cell's job is to take systems, PCBs, cards, circuits, whatever, that fail testing per customer requirements, and to figure out why they're failing testing. Okay, in a manufacturing environment, you have you have test equipment, right? That's what the tests were for. They were test equipment. Problem is, okay, so we had one customer that their test equipment was designed in-house by them in like the 80s or 90s, early 90s. Very old hardware. When it came time for them to start building new stuff, they didn't have the room to get the new stuff and keep doing the old stuff, so they outsource it. Okay, fine. This company, we would produce that equipment, and it was kind of the money maker for the facility. We had 3 test benches, okay? 3 test benches. 90% of the time, one of them was broken. It was down for some reason or another. Eventually, come to find out, there's a number of cables that were just old and bad, but their engineer, the customer's engineer, came down. The specialist on this test equipment came down and looked at it, and he was stumped for a while. Should tell you something. Anyway, you put it on, okay? You have the circuit, right? Say you have this circuit, call this a PCB, not a completed assembly, right? Just the PCB, which is inside here. So you take this unit, you put it on, you take your cables, blink, 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 connect all your cables up, and you put in whatever, you put in the serial number, or you put in whatever information the test requires so that you can track the progress through the facility of all this stuff, right? So it's just standard manufacturing stuff. You put in all the relevant information, you tell the computer, because the test equipment was universal for 20 different assemblies, so you had to tell it which one it was testing, so it'd know which pins it wants to do things to, right? And you hit go. Tick, 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 runs through all its tests. Some tests take a short time, some tests take a long time. Some units are, everything is short, so it's quick. Some units, they only care about 1 or 2 things, and they run further tests once it gets to the customer's facility. Whatever. But if this thing failed, most of the time, it will say, so here's a good one. We had a series of product that ran on these test benches. Whoever came up with the test program apparently didn't really know what they were doing all that much, I guess. I don't know. If I'm designing a test program and I have safety interlocks and I have emergency overrides and I have all this safety stuff put in place so that things don't blow up and melt technicians' face off or operators' faces off while they're trying to test this equipment, right? Something goes catastrophically wrong. You want it to shut down and not hurt anybody. That's the ideal case. Well, they would do that. You do one of the first tests is safe to power on. And it runs some continuity checks to make sure there's not just a short across high power systems. And it runs that, and it's like, okay, we can turn this guy on. It turns it on, and it sets the power supply to have a current limit, which is another safety system. So, you set the current limit, let's call it an amp. Okay, let's call it 5 volts at an amp. Easy peasy, right? Really common kind of values. So, if it draws 1 amp plus 5 milliamp. Okay, well, it's supposed to draw half an amp. We set the limit to an amp because there's some small variances in parts and machinery. Sometimes they're not exactly the value that you want them to be, no matter how precision you want to try to get. Sometimes you just can't get exactly that value, and a little bit of fudge factor, which is fine. That's electronics. That's the world that we live in. That's the universe that we live in. It's fine. That's not a problem. That's normal. But if it draws an amp at 5 milliamps, that's above the limit. So the power supply in the test bench would shut off. And what do you think the next step was? Do you think the next step was to stop testing and give you an error code that says power supply over range, or test not completed because power supply fault? What I would do, the equipment had that ability. It would send a code out on the data line, because all this stuff was controlled via the main computer, just a computer, a PC, with software designed to control this hardware. It would send out an error code that says, hey, I've shut off, here's why. And it'd give you all the parameters. The voltage was this, the current was this, the settings were this, here's what happened. It would do that. But do you think that was in the test program? No. No, 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 no. Not even close. What it would do is it would continue testing, and everything would fail testing. And if you didn't know to look at the data, you had to know the data that you were looking at and the format in which it was presented for 20 different assemblies. Okay, this was Servicell's job, was to know fully what every test on every station was doing. Okay, there were like 10 Servicell techs over 2 shifts. 2 shifts. 2 shifts. Okay? 2 shifts. Actually, 2 shifts. Read between, that one and that one. There you go. Negative spaces. This is the universe we live in. So 9 or 10 techs over 2 shifts. So you have 4 or 5 on each shift. And the expectation at this company was that every Servicell tech knew intimately every product, every failure mode, every functional test, every what would you call that? Tertiary test. So some customers had systems in their test benches that you could perform other tests that were not covered under the standard acceptance tests or the quality tests. Okay, you had extra tests that you could perform as a tech, as an engineer. And the expectation was that Servicell knew all of everybody in Servicell knew all of these across the board. You know how absurd that expectation is? That's like saying, you expect me, okay? You guys out there in YouTube land, yeah? You expect me to be able to tell you wire colors for the driver rear turn signal on your 87 Nissan Pulsar, or on an 88 Yugo, or on a 2013 Ford Escape, or 2022 Silverado 2500. Like, I have to know these things off the top of my head. That's the same kind of expectation they had, and it's an extremely toxic environment. They've recently, after firing me, they've made some changes. And I'm not here to be slanderous. I'm not going to give you any names so that there's no chance of that becoming a thing. I'm not here to do that. It's an illustration of the kinds of people that, I don't know, you should try to avoid. I don't know. I don't even know where I'm going with this whole conversation. It's just kind of rambling off the top of my head. They recently made some changes. So yes, it's a manufacturing environment. No, it is not mass production at all. The facility is not mass production, okay? They make between 1 and 200 of a particular unit at a time. Doing that generally takes, so each work order from start to finish, depending on the complexity of the product. Some products can go start to finish in a week. From setting up the parts on the racks and everything, going through all the machinery, going through test, and getting shipped to the customer. It could be a week. Some of these take a month. One unit, one of the it's not a test, it's a precursor to a test. So you have a part on it that requires, per the manufacturer of the part, this is in the data sheet, it requires a burn-in period. You get it hot and you just let it run, and that it's a oven-controlled oscillator is what it is. So it's a quartz crystal that it's a piezoelectric effect that creates, a sine wave at a specific frequency, a very precise frequency. And the way that you make sure that it's going to work in the field is the same way you do brakes on a car. You bed it in before you give it to the customer. So they manufacture it, they test it to make sure it falls within specs. Then you take it as a manufacturing plant, as a middleman, as an assembly manufacturer. You take it as an assembly manufacturer, you put it on a PCB for a customer, you manufacture this part, or this PCB, and then you turn it on and you let it run. Okay? If after 24, 48, 72 hours, whatever the time span is the manufacturer tells you to run it, it's called burn-in. If after that period it is within spec, the probability is, and all this stuff is statistics, right? The statistics, the probability is that part will have X number of time after that. Based on their testing over a period of this long with this set of test parameters, they found these characteristics for this particular part and this particular design. So you follow the data sheet and you burn it in and you get it kind of set to whatever frequency it's going to do, and then you're done, right? So you have some assemblies like that where they're just on a bench running, just freewheeling essentially for 24, 48, 72 hours. Whatever the OEM, the manufacturer of the part decided. So that takes time, right? That's time, that's power. That's power. You've got to supply these things for that entire time. Right? So it's not cheap, and that means that you can't just make 50,000 of them in a month and ship them out. You can't do it. There's not that many hours in a month. That, or you have to dedicate the whole facility to that bench that turns the thing on and lets it sit there and run for 3 days at a time. Right? So, this facility is a prototyping facility. Granted, some of the stuff has been prototyped now for the last 30 years, but whatever. We're not getting into the semantics of all that nonsense. Suffice it to say, people have done some things, people have made some changes fairly well over the last couple of years. that they're trying to treat the place like an assembly line mass production facility. And it isn't. There's no assembly line through the production floor in that facility. It goes through here in a line because that's how all the machines are set up. And then a person puts it on a tray and then walks it over to somewhere else. And then a person takes it off the tray and does a thing with it, puts it on the tray, walks it somewhere else. And it's not a straight line. It goes like from here to here to here to here to here, to over here to over here, over here and here, into this room to do this, into this room to do this, and it goes in here and it goes out to shipping. Like it's not an assembly line. The facility is not set up like that. The building is not set up like that. There's no way to do that reasonably for all the hardware that they build. But they've recently imposed, so they put locks, electronic locks, on the doors onto the production floor recently. Which means to get off of the floor, you have to badge out. So you have to badge on to get on, because it is a semi-secured facility, the proprietary stuff. You don't want just any schmo just walking in the door, right? So you get a badge in. Makes sense. Perfectly fine. I'm on board with that. I've worked on a top security site before, so it's like I get OPSEC. OPSEC makes sense to me. I understand it. But there's OPSEC at the entry doors. It's a secret facility in which there is one room that is secret, that has its own separate OPSEC, because the facility itself is CUI. It's not confidential, it's not secret, it's not top secret. There's no classification for the brunt of the facility. It's I don't remember what CUI stands for anymore, but it's you know, for your eyes only, for official use only, right, is what it is. Which is most manufacturing. Okay? There's just customer proprietary stuff in that area. You don't want just any schmo walking in there and absconding with it. So badge swipe gets you on the floor, fine. It takes 1 second pushing the button to unlock the door, and pushing the button to unlock the door sets off an alarm. You have to badge off the floor. They told everybody, oh, well, this is for OPSEC. This is because we don't want people coming in and taking documentation that belongs to customers. It's absolutely not for that. If you got on the floor without a badge, then apparently you've got someone helping you. You can get off the floor without a badge. Like, come on. Then, shortly after that, because everybody knew what it was. It was somebody, somewhere, specifically the site manager, is where most of it comes from. But somebody somewhere decided, oh, I don't like that people can eat lunch whenever they get hungry. I don't like that people can have a coffee whenever they feel like they're drooping in energy. I don't like the fact that people are moving on and off the floor willy-nilly whenever they feel like it. They have to go to the bathroom. No. You have set breaks. Everybody saw it coming. You start putting badges, you have to badge out, and set breaks. And if you go 1 second over your break, you get written up. If you're on site, okay, so you're on site, but you don't clock in until there's some time period. It's like 5 minutes. 5 minutes from the time you're supposed to be at work. If you clock in 1 second after that 5 minutes, you get points. You get points. You get points. So many points, and you get written up. So many write-ups, and you're fired. And they're trying to treat, well, I mean, they're trying to treat it like a sweatshop. And it's not going to work well for them. I can tell you that. I can tell you that. So I'm actually not that entirely upset that I was fired, given what they're doing to their employees. You know? Because, I'm a free spirit, man. I can't be held down. I have a problem with people looking over my shoulder and telling me to hurry up. I have a problem with people telling me that my body must work a specific way because they deemed it so. I have a serious, major issue with stuff like that. Like, bro, my poop is gonna poop whenever it wants to poop, okay? There's no way you can tell my bowels when to function. There's no way you can tell my stomach when to be hungry. My body's going to work the way it works, and I'm not going to deny my body what it wants. I'm not going to cause ill health because you think I'm taking a 30-second too long a lunch. No. No. Not cool, Kimosabi. Not cool. And I've been places like that before, and I left. I'm like, no, I'm not dealing with that. The job in Vegas was semi like that. So there were times where you would be, so I had two jobs. One, maintain the equipment, the circuitry, the wiring, the metal, the screws, the bolts, the torques, the values, the adjustments, the alignments, all of it. Maintain it, repair it when it breaks, and then operate it. So it's technically two separate jobs, right? And I got paid well. I'm not saying they don't pay the people for the job. What I am saying is that they had this expectation that the way the human body works is that you go home at, so let's say you got a normal week, okay, which never happened, mind you, but let's say on the off chance you got a normal week, and a normal week was Monday to Thursday, 4/10s, so it was after lunch and everything, because it's a secure site and there's nothing nearby anyway, you're on the site for what was that? 11 and a half hours total? 10-hour shift, and then lunch, and then breaks, which are federally mandated, some specific time for a specific amount of work time, whatever. No, 10 and a half. You're there for 10 and a half. Because the breaks are included in the time. Okay, so you're there for 10 and a half hours a day. So let's assume you got a normal week. So you're going home Thursday, right? And because it's a remote site, all week you're in a hotel. 2, 3, 4, some hours away from home, right? That's what remote site means. If you ever go and you get a remote job, that's what remote means. You're away from home, okay? And you get paid for it. There's rates and there's scales and everything for all that. That's not what I'm complaining about. I'm not complaining about the money. The money was great. Money was fantastic. But there was this expectation somehow that over a period of 3 days, you go home Thursday. By the time you get home, it's generally 2100, 20 to 2100. So you get home, you're up for another maybe 2 or 3 hours, but you're tired from the trip because travel is fatiguing, and you just want to get home, you want to eat, you want to take a shower, you want to wind down, you want to relax, and do nothing the rest of that night, and go to bed. So you go to bed. You wake up Friday, Saturday, Sunday. Thursday afternoon, you find out what your schedule is for the next week. Oh, well, it's nights. Okay, well, that means I get a little bit of extra time. Which means, over the weekend, 4 days-ish, 3.5, you are expected to flip your schedule 12 hours. And you go in Monday evening around, let's call it 1700. You go in 1700, which gives you, 12 minus an hour and a half, which is 3:30. 03:30, you're getting off and going to your hotel. Okay? Then let's say, on the off chance, that week is just straight through the same schedule, which it never was. So Thursday rolls around and you're on nights. So you go to work Thursday afternoon at 1700. You're there and you leave 03:30. You head back and you get home. You get back into town and home around 08:0900. Now you're fatigued and you're tired and you have to drive from the facility where you hop on a bus or whatever, where you get on company transport, right? So from there to wherever you live. Some people live 40 minutes away from that facility. So now you're fatigued and you're driving in morning rush hour traffic. And then the next week, the expectation is Monday morning. You get to the gate at 05, which means you have to be on the bus by 02:30 or 03, 03:30, somewhere in there. And then the next week was nights, and then days, and then nights, and then days, and then days, and then days, and then nights, and then nights, and then days. The last straw for my roommate was actually this one particular week. So the way our work worked, the way our system worked, was customer would come in and say, "Hey, I want to use this piece of test equipment, this piece of test equipment, this one, and this one. All the rest of them we don't need." So the ones they didn't need generally were on days, and just, you do whatever it is you need to do. You do your preventative maintenance, you go through your task list, you fix anything that's broken that you like, oh, well, we could have a spare of this, so you fix one of those. Whatever. You figure something to do. There's always something to do, right? Most jobs are kind of that way. If you have a job where you kind of sit, you find stuff to do. Because you're there, you're getting paid, you do stuff. So this one particular week, his piece of equipment that he was operating and maintaining was, I think, the only one at our particular location that was being used. So everybody else was put on nights along with him. No. It was nights the week before. This was days. We were on days. So, instead of keeping everybody on nights, which required shift differential, they put us on days. The week after that was nights. It would have made sense to keep everybody on nights, even for the dead week, unless they specifically needed days for something, just to keep the human element healthy. No, can't do that. Shift differential. Can't do that. So anyway, we're doing a flip-flop. So for that 1 week of days that one system was needed, everybody else had a regular standard schedule because they weren't required for a specific schedule. So they were just Monday to Thursday. Was it 5 to 3, 5 to 4:30, whatever the heck it was. His particular piece of equipment, since it was required, and it was required for something particular that required some other alignment of the celestial bodies, so they had to kind of wait for an opening or whatever, I don't know. He was scheduled Monday through Sunday. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. 7 straight days. He was scheduled. Okay? the schedule came out Thursday. Thursday afternoon, generally. So just before you go home each week, you find out what you're doing next week. Which in itself is a bad thing. No, don't do that. I know some places that do that. Don't do that. Tell people what they're going to be working so that they can plan their freaking lives outside of work around their work schedule. They have lives that are not work. Most of their life is not work. There's nothing more irritating at work than not knowing what the heck you're going to be doing one day to the next. Anyway, so he was there. Thursday afternoon, schedule comes out. What do you think the schedule said? Next week is nights. Okay. The mission, the work, the job on Sunday was a late job. So the Sunday schedule was something to the effect of 0900 to I think it was a long job, which I think meant a 12-hour day. So what they tried to do, okay, get this. They tried to, since there was nothing going on Thursday for his equipment, they tried to tell him go home early Thursday, or go back to the hotel early Thursday. There's nothing Friday, so take Friday off. There's work Saturday, so we'll be there Saturday for a later shift. Not shift 2 exactly, but somewhere between like shift 1.5, I guess. It was like 1,000 or 1,100 hours until 2,000 or 2,100 hours. Something like that. Same thing Sunday. That's what the job was going to be for that week. He's like, first off, ho. First off, Friday is not a day off if I'm still 3 hours from my home. You're either going to drive me back home so I can be home and have a day off, or you're going to pay me for sitting in the hotel all day. Okay? That's the first problem. The second problem was the next week they wanted everybody on nights. They were not the next week being on nights, so anytime you were on nights, it's because there was a job. Right? There was a job that required nighttime. So his piece of equipment was requested for a job Monday night, which means he's getting home around 020300 Monday morning. And they want him back by 1400 Monday afternoon. So that's 12 hours. He had actually, I want to say I remember it being not even 12 hours, it was 11 hours. The total time that he had after everything had worked out, getting home, the time he would have at home to do laundry, to go grocery shopping, to get everything ready, to do another week away from home, was 11 hours. And that whole, we'll take Friday off and just stay in the hotel room, blah, blah, blah. They did that so they wouldn't have to pay double time Sunday. They could somehow loophole it and get away with time and a half, which, no, Sunday's double time. If you want me there Sunday, you're paying me double time, guy. But they were trying to be super sneaky about it, and that was his last straw. We're like, no, come on, no. Anyway, where are we at? What are we doing? I want to do the seatbelt. It's starting to warm up. Wow. I thought I'd been here telling stories for a lot longer. It's only been like an hour. Starting to warm up. I'm going to take lead jacket off. Jacket off. Jacket off. Jacket off. We're going to stick it in here so it don't get all nasty. Now, I want to try to, oh yeah, I'm going to try to scrub the seatbelt dilly mabobber here. After I move the toolbox back into a place. I'm going to try to scrub the seatbelt thing here a little bit. I kind of want like, I don't know, a bowl? A plate of some kind? Actually, tell you what I'll do. You guys aren't going to be able to see it very well probably until I get this place kind of sorted. And that's it. I'm going to take it over to the bench real quick because I don't want to do it on this table and ruin the table. So we're going to take it over here. I got a little steel plate on top of here. I'm going to use to weld and grind and stuff on top of. I can clean some of this up while I'm at it. Ah, what do you know? Look what I found. 16 mil deep socket. I've been wondering where you were. Welcome back, friend. What is that? Is that Gomer Pyle? He didn't do the crackly voice thing, did he? He just had a super southern accent, right? He didn't do the crackly thing. Oh dang. I don't know. But we can take this guy. Put him down. I also should have put that in the container. I think that guy's on the bottom. That's fine. We're fine. Everything's fine. It's fine. I should really put my safety glasses somewhere where they won't get destroyed, right? Probably the best thing. So why don't we stick them up here on the whiteboard? Wow, they fit like great, actually. Huh? The way the dillies fold, the little arms to the ears. It's like perfect. I don't need this anymore up here, so we can. Put him away. Him away, him away, him away. That's how it goes, right? Okay. Oh, I feel like I'm gonna have to go to the bathroom in like 5 minutes. And we've got a bunch of butyl rubber from the Dynamat. Luckily, Purple Power, being a base, makes things slippery. So it doesn't sticky. No sticky! think that was in the trash can. There's a hole in that end. Oh man. Dance like a 2-year-old. Because it's dance like a 2-year-old day. It's just making up days. I know what I'm going to do is we're going to WD-40 the crap out of the inside of this thing. Because WD-40 is water displacer formula number 40. So we want to displace the water. I'm going to stick it out there in the sunlight. Because as much as I dislike our local Star and some of the things it does, it is quite good at drying things. And we'll then see, what it feels a lot better. It was this fabric was super stiff before, so it does feel a lot better than it did. We're gonna go stick this guy outside. Let him dry out in the sun for a few hours. Actually, not even outside. I'm going to stick it on the back of the Accord. Bam some lambs. I bammed those lambs. You don't know nothing about no bam no lambs. I don't know nothing about no pan of lambs. What you know about Bramble Jam? Keep finding more and more tape, rolls of tape, as I move things around and clean things up. All right, so that is a done. Next step is we're gonna take this guy apart. I can put the simulator away. Don't need less simulator. Might use the O-scope. if I need to do some diagnostics on the volt ohm. I keep calling it a multimeter. It's not a multimeter, it's a volt ohm meter. There is actually a difference between the two. Put this back in the Totally Tote, along with my spare OEM ECU. And, yep, I was gonna have to go to the bathroom. I gotta go to the bathroom. I will be back in just a moment. Don't go nowhere. Or go grab a cruller. I'll see you back here in just a minute. Alright, we are back. Back in blue. Blue. I need a flat little head screwdriver. A one. Not that. Not that. That is not what I need. You go up there. Maybe this guy? Probably more likely this guy. Come on. Come on. Come on. Voice thing we gotta do, boy. Is we got to remove the batteries. Remove ein batteries. Then we're going to have to open it up. Actually, stand by. All the way to the bottom, Cyrillic. Of course, emergency services will never know who to call.
Hello?
What you doing?
Watering my trees.
No trees.
My fruit trees.
What? I said no trees.
No trees.
No trees. What you should be doing is watching my stream because I have a reason. Because
Why?
I'm repairing a piece of electronics equipment, or I'm going to be diagnosing a piece of electronics equipment, and you said you want to learn some of this stuff.
No, I don't pick it up like that. I have to, like, put hands on it. Somebody's telling me kind of stuff.
Well, I can tell you, and then what we could do at some point. Do you have a Discord account?
No.
We should make you a Discord account.
No.
Yes,
I
because.
haven't heard anything good about Discord. I mean, nothing good about Discord.
What have you heard about Discord at all?
Believe it or not, I've heard a lot.
Well, it's currently the only option that allows you to easily do the thing that I was going to suggest we do.
Don't think about it.
And that is you get you'd probably end up having to get like a little webcam, because I don't think the laptop camera, you can't reposition it in such a way that you can type and show things simultaneously, you know what I mean? But what you could do is you get a camera, you set it up on your bench, and I can walk you through the diagnostics of the equipment you have that you need to repair.
Not today.
And Discord will let you do that via screen share and what have you.
You just like making my life difficult. What's going on with your court case?
On the stream, so
Oh,
okay. I guess I can stand by. I can do this. Oh, I'll be right back, folks. if anybody pops in. So I am fully on board with the idea of asshole with a time machine, okay? Moses walks up the mountainside to take a piss, and he sees a bush on fire. What's a guy that doesn't know what electric light looks like gonna think a flashlight behind a bush looks like? The damn bush is on fire. What's going on here? Sean is up there on the hillside taking his own piss when Moses walks up there for some privacy. He's like, God? Yes, my child. And, you know, Sean puts on a voice or whatever. It's like, what are you doing up here on this hillside? I'm here to give you commandments. 15 commandments. And then Mel Brooks, of course, drops one, and, you know, we're left with 10. So I am totally on board with you know, asshole with a time machine. But all this stuff, they're like, oh, well, we found out, how do we build the pyramids? Some guy in Missouri built Stonehenge in his backyard by himself with rocks of the same size. It's not that hard.
Well, the thing with Stonehenge is those are several ton of stone that they moved 150 miles.
Yeah.
Well, across water and land.
4 oxen can do it on land, easy peasy.
Yes, but you got to remember these people didn't have even the wheel. They used, you know, logs.
Yeah. And they had the wheel, but logs are easier.
No, at the point the log was not, or the wheel was not yet invented.
The wheels existed for like 500,000 years at this point. Stonehenge is not that old. We've had the wheel for a very long time as a species. People who make the claim that, like, oh, well, they didn't have the technology, like, the Egyptians, they didn't have block and tackle and pulleys. Absolutely they did. They absolutely had block and tackle.
That's also not saying that they did not have a way to use sound to move them as well.
So the one that gets me, is in, where the hell did they find it? Babylon. In Babylon, they found, archaeologists were digging down, and they found a storeroom. And inside the storeroom was like 5,000 batteries. Why the hell did the Egyptians need 5,000 batteries? You're not making 5,000 for an experiment. That's mass production level. That's, I need to go and grab a battery for a thing at home tonight because our lights are out, or our chariot's not working, or whatever the hell you need batteries for. They found like a giant storeroom, a warehouse, a Walmart full of batteries. All these people, they're like, oh, people didn't have that technology. Do you know what was lost with the burning down of the library at Alexandria?
What?
Everything. The library burns down and suddenly there's the Dark Ages and religion rules the world again. People seeking power over others. That's what it always boils down to.
Yep. That's why we're now back to being a me society.
Yep, people wanting power over others.
Huh?
So it's always people always wanting power over others.
Yep.
Me, I would call myself...
They can have power over me if they want to pay my fucking bills.
Right? You wanna supply my projects? You can do whatever you want, guy.
It's like the bitch next door is always wanting to call the county on me for everything I do over here. She ain't paying my property taxes.
I mean, at some point, you figure the authorities would be like, lady, you need to quit making all these false claims.
Well, the last time, which was several years ago, that they showed up here, I told them flat out she was using them to harass me, and if it didn't come to a quit, I was going to, or a stop, I was going to contact an attorney and sue both the county and her. I haven't heard from them since.
She probably called again, and they were like, lady, listen, shut the hell up.
No, she emails them, and she uses a false email address.
I'm gonna figure out.
Is there live on there with you?
What?
Is there live on there with you?
I mean, you're on speaker and the stream is running.
Yeah, it's running several seconds behind.
Oh yeah, it's going to. It's even on ultra low latency. You have the electrons have to travel out of my computer. Well, they have to travel into my computer. They have to get processed. Once they're processed, they have to travel out of my computer to the router, from the router to the backbone, from the backbone to YouTube servers. From YouTube servers, they have to get processed again, turned into a stream, the information added to it, the information added to the web page. From the web page, then it goes out of that to back to the server, another server. Then it goes to the backbone. Then it goes to your router. Then it goes to your screen. So there's gonna be a delay.
How long have you been doing this?
July, essentially, when I got fired. I figured it was, people have been telling me for like, I don't know, 4, 5, 6, 7 years, a while. People have been telling me a while that they like the way that I talk, the way that I explain things when I'm like, being a teacher, as it were. And I've had 3 or 4 people be like, you should start a YouTube channel, like just put this stuff out there.
I thought about it, but I don't have the equipment, so I'm not gonna do it.
Yeah, funnily enough, I bought the Canon, the camera that's on big right now.
Well, and I keep forgetting to take pictures of those zoom lenses.
I don't even know if you've told me about it before.
I did. Well, like a month ago.
I've blinked since then, bro.
I'm not a bro. I got
Bro.
boobs.
When that moment you realized that you started saying bro being ironic, making fun of people that say bro all the time, but then you realize you're just a guy that says bro all the time.
Exactly.
I don't say it all the time. I generally, if I do say it, I'm saying it like I just did, where I'm making it a point to say it, where I'm like, "What are you doing, bro?" So I say it more than I ever had 5 years ago, but I still do it ironic. I'm not just a guy that says bro.
There you are.
No.
You just called your mother a bro.
As a joke, yes, it was funny.
Only to you, dear.
I'm sure anybody else that, well, people don't watch VODs, especially on YouTube, but if anybody decided to watch the VOD, they would be rolling on the floor laughing. ROFL.
ROFO, rolling on the floor.
ROFL, yeah. Get with it, yo. It's what the homies say.
Homies?
The homies.
I'm a homie.
The
I'm
kids.
a homie. I never leave the house.
It's what them youngsters are doing, dog.
Yeah. Bro.
I'm hip with it. I can get jive. I ain't no turkey.
Oh, there are toilets on the TV. Lots of toilets. Lots of porta potties. Stacks of porta potties.
I'm trying to figure out where this frickin' resistor is. Supposed to be a resistor here.
Hey, Jakey. Brian says that I am a crazy cat lady.
Crazy cat lady.
That's fine. I can be crazy. No problem with it. Most of the time, it gets neighbors to leave me alone when I'm out there yelling at myself.
Go out there and just pretend to be Daniel Radcliffe for a little bit.
They really get to leave me alone when I call them some nasty words. But nobody bothers me. Haven't bothered me lately since I, got off on 2 of them. The 2 worst ones in the neighborhood.
I mean, at the end of the day, that's, Oh, I need to answer this. I gotta go talk to my landlord.
Alright.
So, I'll talk to you later.
Love you.
Bye. Hey,
Hey.
it's Ryan at 293 West. I don't know if you got my number saved.
I do, yeah, it's Ryan.
So, we had a slight lawnmower malfunction, and we were wondering if you had a fence guy that could come over and take a look at a fence.
Do you guys have a vinyl fence there?
Yeah, I don't think it belongs to this property. I think it belongs to the neighbors, and we chucked a pine cone through it.
So I don't have something that I specifically use for vinyl fences. I do, however, have a tenant that works for a fencing company that I could probably have come over and look at it. But I mean, I've never had him personally do work. I do know that the fence company he works for is pretty reputable around the valley though.
Okay.
So I can get his contact information and send you, or you can just look some like a fence company up online, whatever you prefer.
Yeah, if you want to try to get a hold of them or get the info, I can try to get a hold of them. And then if they're just like, yeah, call my boss and you know, set it up like normal, then we can do that. I just wanted to make sure you guys didn't have somebody you guys dealt with normally already.
Yeah, not for fences we don't. So I'll reach out to him and I'll let you know what he says.
All right, I appreciate it.
Okay. Yeah, no problem. See ya.
Thanks. Bye. Okay, that was quick. I probably could have just put you on hold and gone back to you, but I think you got stuff to do anyway. So I'm trying to figure this out. I was sitting here jibba jabbing, not figuring this out. So what I got to figure out is why AC doesn't work. I wish I had a photocopier or a printer. I think I still have this as a digital copy. And my right ear is still screwed. It's been screwed up for a couple of days. I'm missing 40% in my right ear. It's really annoying. And I'm pretty sure the issue is these diodes. Okay, so we got the meter. Comes down to the switches, right? So when we put it on AC, we're on this guy. Comes down to 102B. Which is what? The voltage selector, right? I've never dealt with this kind of switch in a schematic. I don't quite know how to read it. Because they're multi-plane switches. I don't know. I don't know how to read this schematic with them. I don't know how to read multi-plane switches in a schematic. Okay. I don't know if these are all the way down. Do they just contact straight through when you turn them? I think they are. I think the post is common across the switch. Wait a minute. What? What? Oh! The schematic tells you. Oh. Okay. So you're like, I don't know how to read this. So all of these, I believe, are common to each other through the central shaft of the switch. What you get is a tab there, a ring there, tab there, tab there, tab there, tab there, tab there, tab there. Pretty sure the tab is what's connecting things. And then that ring is... So where this tab is, that ring is 2 switch positions off and 50% of a circle. And when it is on AC, nothing's connected to it. That is only for the resistance, it looks like. Okay. So, what I need to figure out then is what is connected. AC. The problem I'm running into is when I put it on AC, it's showing me DC on the meter element. So work backwards from the meter. I'm pretty sure it's CR101, A and or B, which would be, well, I'll show you in a minute. Oh, this chair sucks. Too low. Actually, that's what I can do this week. Take those struts, pull them apart, and make a seat out of them. Oh man. We're gonna go check on my seatbelt real quick. Sitting out in the sun. We'll see if he's dry. I need to stand. Just a moment. I think that's dry. Don't look too bad. I'm gonna go take it out and check it on the seat belt and the Civic. But yeah, I think it'll work okay. I got WD-40 coming out of the bits and pieces there. That's fine. I'm gonna put some lithium grease in here. Yeah, he's pretty much dry. Doesn't look too bad. Not the light brown that it's supposed to be. But, you know. Okay, I don't want this over here anymore. I'm done with this guy, I think. Well, still gotta wipe the inside of the case. I want to clean the inside of the case out. Alright, so problem is CR101 A and B are calibrated Please wait while we calibrate the nozzle. Oi! Oi, oi. Okay. So, wait, what? Is somebody outside? Sounded real close. Huh. Yes, guy. Not for us? Not for us. It'd be nice if my my cords were here. That'd be super nice. There's no way. No way. Oh, jeez. Need a better chair. Who wants to buy me a chair? Somebody buy me a chair. I need something with no back, with an adjustable height, on decent, well, casters don't matter. I can modify the casters if I need casters. But, need something higher. Because this little shop stool thing, it's used for like, you know, working on cars when they're on jack stands and they're right below the ground. It is not doing it for me. And I like to keep him stock because sometimes I need to be that low sitting. So like, I need a chair for this bench in particular. That's what I need. Stuff for me? Stuff for me? No stuff for me? UPS guy's rude. He ain't got nothing for me. How rude. Ugh. Oh, it's terrible. Tell you what, actually. What I was doing previously is I put some toolboxes up on this. Let me try that again. It was uncomfortable because they were hard. I didn't have the foam. So, I'm gonna lube these wheels. They're kind of noisy. I guess we're gonna have to lift up the toolbox and figure out what the heck's going on later. Later, not today. Later, not today. Okay, so. Toolbox back, where do you go? There you go. That's what we're gonna do, see? What we're gonna do, see? Look, alright. The fender hammer set, fender hammer and dolly set. And then we've got a socket set. What you call that? Axle nut socket set. Oh! It's much better. Oh yeah. Okay. That's a much better. Now my legs won't go numb just sitting on the darn seat. Alright. So we've got to go through this schematic. We're gonna turn on. I'm gonna turn on the Logitech, but I want it to be closer. Means I gotta pull table further away, which apparently means, oh, I'm pushing the leg, pushing the foot, le foot. Pull that away from there. Empty cup over here. Pull whiteboard. Whiteboard. And this whiteboard is really annoying because the wheel brakes apply themselves. Somehow, someway. Every time I touch this damn whiteboard, the wheel brakes are on. I'm gonna have to move. Probably gonna have to move this head too. I think it's in the way. Move le cylinder head. This guy has got to go somewhere that's not here. Blah, blah, blah. Not light. Not light, not light. Not light, not light. Ugh. Okay. Well, you can sit there for now. I'll have to move them later. But if we now grab the whiteboard. Come on. Oh, this stupid thing. Stupid thing, stupid thing, stupid thing. What is wrong with you? No, wheel brake. See? Wheel brake. By itself. Nothing touching it. No idea. This one too. Wheel brake. Quit. Figure out how to disable that thing. Okay. Hey. Kind of like that. Then we'll push it back. Headphones. I don't like it there. Okay. Now, sit back on le seat. Turn le Logitech. Logitech. Okay. We want kind of like that. Then I can just show you guys some stuff, just so you can see kind of what I'm doing. Right. Now, this is the stuff that I will say takes a little bit of thinking power here. Most of the stuff I do doesn't, but this is the kind of thing that, like, you gotta know a little bit about what you're looking at before you get into it. But it's kind of why I'm here. Kind of walk you guys through some of this stuff and show you that it really isn't as hard as some people make it out to be. And I've met some people that try to make it out to be a lot harder than it really needs to be. So, move you over there somewhere. Alright, so we're looking at this schematic. So, it took me a good 3 minutes to figure out what the heck I was looking at here. Right? And this is it. This whole thing, this entire piece of machinery right here is this page. That's it. Super simple. Which is why I like it. I like things that are simple. I prefer this over a digital multimeter any day. Digital multimeter has some functions. It has some useful purposes. Absolutely. But for voltage and resistance, you can't beat just a good old-fashioned voltometer. I mean, unless you're doing, precision measurements. If you're doing precision stuff on new equipment, and you need to know, 1 millivolt or 15 microvolts, then yeah, absolutely, you're going to need something new and digital, signal processing, etc., etc. This thing will load the circuit up way too much. Even with its own batteries, you load the circuit under test up way too much with a piece of equipment like this. So it has its place and its function, and it's excellent at what it does. There's a reason we use them for so long. And so, looking at these, I need to be on AC voltage. Okay, so AC voltage is going to go to this guy, and go to this guy. Is going to go to this guy. But we turn him so he is not connected to anything. Okay, he's going to go to this guy. Okay. This looks like it's going to be a ground connection. It's common across all of those. Yep, there's your common right there. Okay, so that's our common. So we don't necessarily care about that. Because we know the common is just going to stay in the common connector. We know that. So we can ignore all of those that go to this common line. Right? So now what we're interested in is all the rest of that. Alright? So let's assume for a moment we only care about the AC switch, because DC works, all of these work, all the settings work on DC. So the range selector is 100% functional. Okay? What we get when we hook up to AC, which we should be able to do low voltage AC on the volt milliamp ohm connector, right? That's what the book says you do when you do AC voltage, low voltage, which, you know, 15, 20, 30, 40 volts, low voltage. So that's what we care about. We care about anything that comes in from this connector. Someone's making a bunch of noise out there. I think someone's doing some renovations. Saw some guys loading some big boxes into a house. So, look like washer and dryer or dishwasher or something like that. So someone's changing out some piece of equipment. Alright, so from the AC connector, which it's weird that, why does it? Well, we're not on there, so we don't care. Wait, does this long line mean it's always connected? That might be the case. So some of these have a long line on them, like a long arrow, from the connector to this ring, which this ring is conductive. You can see it on there when you look inside. So what we're doing, we're following, so when we switch this to here, bang, oh yeah, that is always connected. Okay, so long line means always connected. So when we turn him to here, we connect volt milliamp ohm at this ring to ACV, which comes down here and goes to here, which is always connected to this ring. Gotcha. Okay. And from there, we select, this is the voltage range. So we know this, all of these resistors are good. Yeah, okay. So all of these resistors are good because when we change the range and we're on AC and we put it on a DC source, we just see the DC source. What that means is we're not filtering DC. So where are we filtering DC in this whole circuit? The only place that is going to be filtering DC is these. CR101, which is the rectifier. So R111, R12, or R111, R112 could be bad. They could be shorted. It happens. Rarely, but it happens. Or CR101, A and or B could be shorted. That happens. If they are shorted internally, we could be getting they drew that battery weird. Okay. And then that guy's coming. Yeah. So the only place that there can be a problem is CR101. Okay. Because we know all the rest of the circuitry works. All these resistors here, they work. All of these resistors have to work because they work on DC. And what we're trying to use is this 25 volt line. Comes over here, resistor to common. Resistor here goes to this guy right here, the bottom of that rectifier. Well, not the bottom, the AC output. Because as it back and forth, it's going to go here or here, or here or here, or here or here. Right? Okay, so how do we get the meter to AC voltage? That's the next thing I want to find out, just to be safe. Pretty sure, 98% certain, that that's our issue. But we're going to check the rest of the circuit to see if any of the rest of it makes any sense at all. So the meter is always connected to there, but we would connect to this pin. There's no connection there. The meter is always connected to this ring, which does have a connection there. That is common, which is this guy right here. Comes out of the rectifier. Okay. So when we're on AC, that's that connection to that side. Good. And so from here, turn to here. Yup. Okay. And that is DC, AC, output, and DC milliamp, an amp. We'll drive that side of, which is probably the power side of this, what you call it there, meter, galvanometer. That line also goes to the resistance measurement ticks, but we're not touching those, so we don't care. Now this side, this is at the 0 point, right? This ring. So when we turn him this way, this edge is going to move this way. So it's not contacting anything there, so we don't care about this line. Now we come over here. This one is always contacting this ring. We come here, AC. That comes down, and that is our rectifier. So one side of it goes to battery ground, the other side of it goes through the rectifier. That's our circuit to our meter. All right. That's it. Super simple. It's, let's see. 1, 2, 3, 4, 5, 6, 7. 8, 9 parts total. 9 parts total in that circuit. So what we can do is we can check the resistors. There should be in the book. I don't think you guys can see that all that well. So in the book, it should give us how these parts are set up, I believe, on the inside of this thing. Yep. These pages right here. Okay, so we start here. We scroll through. It even tells you how to open the crate when you receive the tool on the ship. This is a naval variant. So cool. So very, very cool. Alright, so front page, turn it over like a book. There we go. I should really put holes in this and put it in a little binder. Alright, so this is the inside of our thing. CR101. This guy right here. CR101, it's got 2 diodes in it. Yeah, so we don't necessarily care about that guy. But it tells us where stuff is. That's what we really care about. Okay. So I'm gonna have to reorganize these pages when I get done with them. Alright, so we are interested in, here is one switch, here is the other switch. One switch, the other switch. One switch, the other switch. So, we're going to start on this one. We got to figure out which switch this is. S101F. Alright, S101F. Oh, that's the mounting plate. F, the designator. So S101 is the one we're interested in. It's this top switch here. He's got 1, 2, 3, 4, 5 different plates or contactors, right? And we want to check the resistances of, on S101, R140. Okay? So R140 should be 5,200 ohms. So we're going to put them on 20K so we can check, you know, up to 20K-ish. And then we're going to find R140. R140 is thing looks heck. Camera's making noise. I think the tape is old. Okay, so R140 you guys go up there. I gotta figure out how to read this. Not quite sure how to read this. Okay, which way do those screws face? There are two mounting screws and then the central screw. It appears. Alright, and we're facing... Okay, the perspective of this thing is drawn quite weird. So R140 is on the middle contactor panel. I don't know which way is the zero contactor. Okay. So this is... Which panel is this? BC. So you got A, BC, and DE, right? So BC is this guy, and that's the middle contactor panel. It says there's 3 contactor panels. I see 2 contactor panels. Why do I only see 2 contactor panels? What? Well, tell me this is the wrong book. What? This is interesting. Why are some of these contacting and some of these are not? I don't think it matters. I think it's for wires to get soldered onto. We're gonna check real quick. Just kind of double check. Prop him up a little bit. There's rivets that go through these guys, so I think they're electrically common. Yeah. Okay. The way the switch is constructed is a bit strange to me. I'm not used to working on this kind of older equipment. The equipment I'm used to is 80s, 90s, early 2000s. That's kind of the stuff that I am most familiar with. I also don't know if that capacitor is in good. That capacitor, C101. Gotta figure that out. C101. C101's a big guy. Okay. We don't care because he's not critical to our circuit. Sweet. Okay, so what am I looking for in R140? Why does that... The switch, the image of the switch construction does not match the physical switch that I am looking at. And that is a concern to me. Because this appears to indicate that there should be some side plates. But it doesn't really matter. I can check the pin, because that goes to red, right? Yeah. The red to CR101 goes to the resistor there. And so if first I gotta figure out which pin on the switch we need. I gotta tighten that screw. That thing's loose. Wow. Okay, so we need to turn this, actually. I need to turn this. I need to turn this. I need to put connectors on these wires. Or a connector. Just a connector and stranded core wires for these battery. So you can just disconnect the thing. That would be... I might have connectors somewhere. Might have to look for connectors here in a little bit. Anyway. We're going to kind of turn him up on his end a little bit. Okay. Where's the fuse sit? Insert. I don't remember. Fuse. I'm pretty sure the fuse is the whole thing. Where is the fuse? Depends on how they drew the fuse. Oh, this might be the wrong book. That could explain some things, actually. If you look at this, this shows what that page shows. This bracket and this organized arrangement of resistors here. That's not what I see in front of me. ME48AU. This ME48AU? I'd have the wrong book. ME48DU. Okay. So this is a D model. Whatever that means. I am gonna, ow. So maybe the D is not the naval variant. Maybe this is a different variant. I'm gonna have to look that up. Wow. This whole time, everything else has been the same so far. So like, this is the first time I've actually had to get into the schematic and the construction. ME48D U. Yeah, maybe. Helpful. Archived sites. Images? No images? It says there's images. There's no images. Simpson, ME48DU. No idea what that is. I need the book. Because I don't know if these values are the same. That might be why it doesn't work. Because I did replace a resistor with one that was burnt, and I couldn't read the value. And I used this schematic to figure out what that resistor was supposed to be. Oh. Well then. I'm going to put this on. Yep, it's already there. So, diode. So, one guy. Okay. That was weird. Well, they appear to be diodes. Still. So why would an AC signal not appear to be an AC signal? R112, R111. R140. Assuming the schematics are similar, which I don't have to assume, the schematics in the freaking box. So, from AC, where's AC? AC's there. Okay, we're going to have to turn this around. Schematics in here. Okay, so we move to AC voltage, right? That's click, click, 2 clicks. Where's my pick? Oh man. Maybe I use a schematic in the box. I hope I use a schematic in the box. This one. Click, click. Okay, that's going to attach this guy. Which is, that sign goes to there, goes to there. Those are the same. Okay. There. There, and that goes nowhere because it's going to be there. Okay. This one's harder to read. That connects the probe. This guy. Okay. Go. 3. Okay. That connects to nothing. That connect that guy, yep. That guy. Okay. The schematics look identical. They're just drawn differently. Which means R140. There's R140. R140 is on S101. 101B. There is no 140 apparently in this guy. Okay. Sure. Okay, so then what am I looking for? I guess 111 and 112, which are the identical values to these guys. This guy doesn't tell me what diodes. Oh yeah, it does. IN26. Ooh! They are different. Slightly, but different. Okay, so what I need to do then is check R112. The place where both of them are connected, so that pin, yellow, right? So yellow connects to a resistor on the bottom somewhere. Okay. I still don't see that fuse in here anywhere. I don't know where the heck that fuse goes. Where's the... Oh. R112 and R111 are these. Weird. Yeah. Well, that's not right. That's close. Yeah. This guy's supposed to be 1K. He's 875. He's way off. Oh, but that should not make it to where the AC circuit simply does not work. What if I replace the resistor with the wrong value because I read the wrong schematic? What would happen in that case? Which ones were the ones I replaced? That's the question. $25.1. R133. That would be the one that's supposed to be on 25 volt. Okay, so 133. 5 volt. So from there, you are 1, 2, 3. On the line. $25.1. Same thing. Okay. That's good. This guy is a... all 4 of those look new, don't they? Okay. Still got the boxes of those guys somewhere. Just because I'm curious. Fuse is okay. Where does this go? AC voltage. Huh. Okay. What value is that? $1860. There's an 1860 that comes off of this one. I wonder if that's supposed to be R140. which one does that come off of? Off the inner, so the upper plate. The upper plate is going to be the top plate A. That line goes there. Oi. Trying to figure out where on this schematic I found that number. Okay, so there's that guy. 18.3. I think I did use this schematic. But it's been like 5 years ago now since I did this last. Oh. Okay, what's the next one go to? Those are all common together. So there's not that guy. Purple, that one, blue, white. Black is the one right after the underneath black. It's that black, which goes to the meter. Yeah, so it's R139 in there, R139 in there, 18.3. Okay, that's fine. Then the next one, where do they all go? They all go to it's this guy, right? On that switch, they're all okay. 6, 7, 8, and 9. Okay. Probably those. There's that one, separate. And then 1, 2, 3, 4. Yep. 4. Okay. So they got 5 there. What? 1, 2, 3. Yeah. What? Six total. Okay, what line are those attached to? Comes over to the bottom plate, so that's probably D. So that's going to be... Yeah. Same thing. C. Okay, so let's read these values. What are these values? The values will probably tell me what they're supposed to be. $300. 107. They're 18. Wait, what? $18K should read here. Okay. 18.2K. I don't have another 18.2K on it. S101. Got that guy. Got 27.5. I'm gonna have to disassemble this whole damn thing. Okay, what is this guy? Lower right. Lower right. 25.7. That could be 106. Ah! Okay. What the heck did I do? This is why you take notes. Because, I can't remember what the heck I was doing in here. I know I replaced these wires because they were just like, the insulation was falling off of them. I remember that. This might be a longer problem than I thought. Um. Bum, 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 bum. Whoa. You know, Mr. Wire that I didn't replace, you shouldn't be running across that shunt. There's a shunt wire between common and 10 amps. Where is 10 amps? Yeah. Resistive wire that goes between common and 10 amps. There's a wire that's on the 10 amp post. Comes off and goes over there. Can't really see. That goes to a common bar. Connects a bunch of different stuff. I mean, I guess they're common together. Looks like that got hot. Melted into the insulation of the wire. 99% certain it has nothing to do with the problem at hand, but we're going to separate them anyway. I like that. Maybe it's not hot. Maybe it's just because it's been sitting against it for so long. Oh, man. Well, this is, more sticky than I thought it was going to be. Because you can't easily remove the PCB from the case. You have to disassemble the whole thing to get it off of there. I have this feeling, as old as it is, that I don't know what vehicle that's coming off of. Funny reflection on the wall. Anyway, a feeling that's trying to pull this thing apart, things will fall apart that I don't have the methods, the tools, the knowledge, the skills to repair. That's my fear. I was just talking about this morning, right? You just gotta like screw it and jump into it. I really like this meter. And I want to get it fixed. I guess take my own advice. And I just get right into it, huh? First thing I'm going to do is I'm going to remove the wires from the rear case, the battery tray. To that end, we're going to begin taking pictures. bunch of pictures. Well, might need some extra solder. Or we might just need to do tip maintenance. Huh? Don't really have the power. Iron. I mean, it's a 50-watt iron. I don't have the tip. That's the thing. I don't have the tip. Okay. Rear case. Remove it. Pull the seal. We're going to start putting all the parts in here too. Actually, what I should do is get a little bin instead of this so I can use the schematic still. I don't have a little bin. Oh, I guess we're just going to set the stuff on the table because we want to keep this free for the schematic. Okay. Does cover come off? I think, yeah, the screws are in from the back. So that means we pull these screws off. 8, 6, 7, 6, 8, 6, 9, 10, 6, 11. Okay, now we got a screwdriver. So we gotta pull the switches apart. Pull this thing off of here. This is always the kind of scary part to me. Because I remember trying to put these switches back together last time was about a nightmare and a quarter. Oh. Wish I actually had the book for this piece of equipment. That would be very, very handy. Oh, there's another nut there. I'm missing parts. Huh. Wonder if somebody else had been in here before me. I don't know. Okay. Well, I need to pull a little bitty, itty bitty screwdriver. Do I have one out here? That little set. Where's that little set? I don't know. I guess I gotta go grab the ones from inside. I will be back in just a second. I'm gonna go grab my little tiny screwdriver set again. Well, just a screwdriver. I don't need a set. Is it still out here? Did I leave that screwdriver out here? I'm gonna go grab that screwdriver inside. Well, let me go grab that screwdriver from inside real quick. You know, that one. Don't be losing parts, please. Yeah, all those spacers. The switch. Okay, we're gonna pull. Switch covers, handles, plugs off. Gonna pull the 0 ohm knob off. We should be able to figure out these switches are going to be super annoying to get back together. Pretty sure they were last time. Little needle nose pliers. We're going to take a picture of these guys. Okay. Picture of these guys. Picture of this. Because last time I didn't actually sit down and go through the circuit. I just tried to replace the resistors that were faulty. Some of them I could measure. They were just slightly damaged visually, so I just figured I'd replace them. And I measured them and I replaced them. Okay. Yep. That's just gonna have to be unsoldered. So this time, we're going to take it all the way apart. We're going to discount double check everything. That's how we're going to do it this time. Who wants to see a shunt resistor, old school style? Shunt resistor, old school style. 0.025 ohms. I don't even have anything that precision. Measure it. I don't wanna let fear rule my life. Everybody, go tell your friends. Riveting content. I'm the most entertaining person you'll ever see. Okay. Oh. Are these? Oh, these might be trim pots. Okay. Tell you what. The one that connects the ends is 1,000 ohms. One that both of them is connected to is 1,500. This guy must be 1,500. They're not trim pots. Okay. I didn't think they were. But they were just spinning. There's nuts underneath them. Okay. Come on. Eee. Mother Fletcher. Huh. That's the weird resistors. Yeah, we're gonna trace this whole schematic. I'm gonna measure every single resistor. So, welcome to the channel, folks. Today on But It Runs, Measuring 50 resistors, one at a time, following the schematic the old school way. Sometimes you just gotta do it old school. Picture time. Come on. It didn't want to come, but it's off now. I guess good news is this is leaded solder, so it's very low melting point. Oh, that's got a through hole. Interesting. Okay. There we go. Okay. Now, with this PCB removed, do I want to take it all the way off? What is the question? Do I want to completely remove it, which is just those two wires, 4 wires, 2 on the pot and 2 on the meter. Oh, gotta stand up, gotta stand up. It would make it easier to go through the circuit with the meter and the pot removed, because I can isolate sides and such and things and deals and what you have. It's yeah, I guess we gotta, don't we? We gotta, don't we? What I should do is I should remove all this solid core wire. I even replaced the solid core wire with solid core wire when I did this thing previously. I should replace it with stranded. Is what I should do. Because there should not be any major problems with that. I mean, the wire on the pot stranded. Okay, take some more pictures. All right. I'm gonna solder sucker up some of this stuff. Not sucker, I don't have a sucker anymore. I need one. Anyone wants to order me one? I'm going to solder a wick. Will these work? Yeah. Okay. Gonna kind of prep all these surfaces. This is the stuff right here. This is my bread and butter. This is what I enjoy. These posts take a lot of heat. Come on. I can see you getting there. Come on. Come on. There we go. Gonna clean the pot. Sometimes you just don't have enough flux. That's sufficient. These little guys are super easy. That's why I left them for last. Bam! Holes clear. Let's trim that. I can just burn my pinky laying it down on that one of these posts, because they take a lot of heat and they thereby retain a lot of heat. It's called thermal inertia. Sort of. Okay, so meter assembly is removed. I wonder why. Also, this is what's great about Bakelite. It takes a lot of heat to screw up Bakelite. Where the heck my pick go? Hello? Mr. Pick? Mr. Pick? The heck? There he is. What's it gonna do with the pick? Don't remember. Oh, little piece of solder here. We don't want him falling inside a circuit when we're trying to use the thing later. Also, now that it's taken apart like this, it'll be easier to clean. I can clean out the inside really easily. So that's handy. Doing this for 4 hours. It is 1300. I guess the question is, do I want to pause for lunch? Tonight, I'm gonna make some red meat sauce. I went to the store and forgot sausage, so I had to go get sausage this morning. And I got sausage this morning, so I can now make a red meat sauce. The last time I tried pepperoni, along with just beef and sausage, ground beef and Italian sausage. And, wasn't a big fan of it. Seen people put some pepperoni and other types of meats in their red meat sauce. Usually better known as spaghetti in America, I guess. And yeah, I like beef, ground beef, seasoned ground beef, and Italian sausage, like a spicy Italian sausage or a mild Italian sausage. That's what I like in my red meat sauce. I think I'm going to take a break to eat something. I don't know what I'm going to eat though. Probably just ramen. So, what we're going to do is we're going to change this guy to... Really? Go! Go! Hey, we'll be back in a bit. I'm on lunch. 20-30 minutes. Doesn't take me that long. Well, I was going to say I might bring my lunch out here, but no. It's a bowl of liquid. I'm not going to bring a bowl of liquid out here. So, we'll be back in about 20-30 minutes. Don't go nowhere. I should put a return time on there too, huh? How about that? Put a return time on there. Let's go 13:30 Mountain Time. Ah, it's not even on the screen. Where are you? Ah, yes. Once you tap to there. Why is that not... I would like you to just be centered. Could you not, like, center? Guess there's no way to... Oh, there he is. Yeah. There we go. Alright. So, I should be back 13:30 Mountain Time. Let's try that. Okay, be right back again. Would it be easier if we did this? Do that. For this part. So we've got our PCB out of... That guy's captive. Do we have... more nuts, right? That nut's still in there. That's what we're gonna do. We're gonna reassemble the switches. Real quick, real quick, real quick. Okay, I'm going to reassemble the switches because there's nuts in here. Retention nuts. Hold these guys in place. And it'll just make putting them back together, I think, a teensy bit easier once we get back to the other end. What I really wish I had is the same thing I keep saying I wish I had over and over in a bunch and a bunch. And that's helping hands. Helping hands would be very, well, helpful during this entire process. Okay. Oh. I forgot the washer. Forgot the washer. There's supposed to be a washer. There's also one missing. Okay. We're also missing a nut? No, we're not missing a nut. Meep! I've dropped the bolt! I dropped the bolt! Oh no, I dropped the bolt! We're gonna turn you off for now. Well,
easiest way would be to put the bolt in the nut first and then put the spacer. Okay, now we put the spacer. Put the spacer in the gap. This is not the easiest thing to do. I don't even know what kind of accent that is. Yeah, I need tinier pliers is what I need. Huh. This guy just will not go in there. Ruh-roh, Reggie. He came out. He's got to go back in. Oh, he won't go in because the pliers are too big. That's why he won't go in. So we got to figure out some method of getting it back in there. There we go. Ta-da! Okay, now media one goes in there. There we go. All right. That one's still in there. That one would be a pain in the rear to get to. That's for sure. No. I thought I dropped it on the floor. There we go. Easy peasy. Sweet. Alright, now we can measure the switches. Can I pull the switch out of here? That looks like the shape of Iowa. Tell me, is that Iowa? I think it's Iowa. That's just a 10K pot. Nice. Okay. Oh. Pick that up because I need this. This is going to be the fun part. Do I have? I do. Interesting. There should be something through there. Where did those resistors come from? They came from 1,000 volts. Okay, so from 1,000 volts. So one should be 10 meg and one should be 500K. $500K. 10 meg. Okay. A little bit less, but fine. That's fine. Okay. No. What's this guy? This guy should have 98.8 meg attached to him. He does not. That's a 5 meg. Okay, what the heck is going on here? Even this is wrong. Huh. What? Hmm. Oh. Duh. Sometimes I'm just dumb. Sometimes I am just dumb. Not crazy often, but sometimes. This is 101. This is 102. Do I have? I have a paint pen. I want to mark stuff. We're gonna mark some stuff. That's what we're gonna do. As we're looking at it, it's this way. This is one. Two. One oh one, 102. There we go. Because I keep flipping things in my head for whatever reason. It keeps. As I get older, it happens more and more. It's disconcerting at best. There you go. You guys ever seen a battery like this while I'm in here thinking about it? .22.5 volt battery. Looks like that. .22.5 volts. I got another one somewhere. Very interesting, that. That thing was kind of hard to find, actually. At some point, I might have to come up with a different solution. Okay, so... 2K ohm for the motor. Check that guy real quick. Okay. You can watch it drive as you apply current, which makes sense. It's not unusual. I'm only saying it because it's funny. It does the thing. It does exactly the thing. Okay. What we need to do is first thing I'm going to do is just look for broken joints real quick. Is this thing kinda likes to fall apart. These traces are not adhered to the PCB as well as one would prefer. Everything looks okay. I have a sneaking suspicion it's those diodes. Because that's the only part that converts AC to DC. Okay, so we're gonna go. Alright, so where is the 0 point? 0 point is. Oh. Let's see. I guess I don't need to take these guys off of here, do I? This rotates independently of that down there. Okay. Interesting. Okay. The thing that concerns me is these pins don't line up with the switch in there. That's in the full counterclockwise position. Why would you draw this way? So they so in the schematic, they drew these switches, okay, right here, looking down at the switch from the top of the unit, like you'd be using it. So like this, with the switches both in this position. Okay? They then drew the switch itself from this position. Because if you look at this tab right here, can we get closer? That little tab right there is connecting those two that are separated by a single pin. Two separated by a single pin. Lovely jubbly. No wonder I've been having such a hard time trying to figure out where these frickin' pins go. Damn thing upside down. I don't even know if I want to finish this thing today or not now. just a diesel. Okay. That one's about dead. Oh wait, no, 22 and a half. It's 24. Brand new. I was thinking 25 for some reason. This makes me less than happy. Kind of means today's stream was sort of wasted on a boondoggle, essentially. I do need to figure out why the heck. So I need to find the book. I need to find the book. This is not the right book. So somehow I've got to find the book for this thing. I've got the wrong version. I need the schematic in a better form than what's on that page. The schematic for this other guy, the switches are radically different. They're a different construction. They're different enough that the schematic won't work. I guess since the Civic's done, the Civic ECU is done for now. Mr. B, go away. Hey, hey, hey. That way. That way. That way. Go. That way. That way. Outside. Thank you. Every day. Where it's the same bee. Says, oh, I'm gonna go see my human buddy. I don't know. I'm ever one of those things where you're like, you have 5 or 6 things you could do, you want to get finished, whatever. You're not quite entirely certain which one you should start on first. I do need to. Some of the stuff I want to do, though, I want to show you guys. I want to have the camera on a long enough cable that I can bring it over to where I'm working instead of working on the bench. Because the bench works fine because I can put the cameras right here, easy peasy. Problem is, I want to have the cameras doing the Accord and doing the Chevy stuff I want to do to those guys. I don't know, man. I could go inside, start work on cutting the Civic's ECU mod video together for you guys. I want to change this buckle. That's the word. I want to change this buckle in the Civic seat from the hard-mounted one to this soft guy. And that's just pulling the seat out of the Civic and bringing it in here. That's not that hard to do. could take all the equipment inside, set it up in front of the green screen to do the 2 or 3 things that I want to green screen. I do need to try to figure out the Versus shifter. Oh, looks like crap. I'd really love to do an update to the Civic's exhaust. Don't have the money or the parts. What I kind of need to do is organize my fluids over there. Ugh. Just don't know. Yeah, I guess I'll go in and cut the Civic video. CU video. See if we can't get him going. Because I need to post a video. Alright, I think that's going to be the stream for today. I've got to think about this guy a little bit. How I want to proceed. Exactly what I want to do about him. I think I want to replace these wires with stranded wire. Get rid of the solid core. Probably end up doing that. Because I gotta order some wires. That's fine. Those won't be too much. Then I think for now I'm just gonna go. We're gonna head out. I'm gonna take the Logitech and the mic back inside. If I get that video cut, maybe I'll hop into a game. You guys can join me in there. Yeah, I will. See you folks later. Have a good morning, day, night, sleep, nosh, jog, whatever it is you're gonna do. We will we'll see you into the next one.